So if you guys can see it, hopefully you can. I just wanted to go over a couple of things. This is going to be super awkward in the recording now, but go over a couple of things. The main question that we're trying to go over, right, is the why do some things fit together and other things don't. So this is meant to be a longer process to go over all of these things. But the main thing is this is the question that we're looking at. And so you guys are going to be doing some more labs later on, doing some other things. Who's writing on my screen? Oh, goodness. All right. So the main thing is we are going to be going over some of these experiments and details, try to figure out why some things fit together and other things don't. Again, it's a slower process, and it was supposed to be that way in class. So if it's like going really, really slow for you, that's kind of on purpose to take our time to try to figure out the answers to this question, basically. So there's two things you guys should know at this point. And that is the first thing we went over was 5 things every scientific model should have. And we did it with this Van de Graaff generator PyPan experiment. Okay, so can you guys all see that screen?
Yeah.
Yeah.
Okay. So from the reading and from this, there were 5 things every model should have. And I picked out 3 random examples from you guys of the drawings that you guys did. Because I wanted to highlight the amazing artistic ability of some of you guys, which was awesome. As well as just to go over what I'm looking for in the future as we start refining what our model should be. So there's 5 things every model should have. Whenever you are drawing a model, especially when you're trying to figure out what's going on, they should always include all key components and observations. In this experiment, if you'll remember, that the pans, the pans started right here, and then they went away, right? That was the idea of what happened. You're trying to figure out the reason why. So when you draw your model, this was before it was turned on, this was after it was turned on. So the first thing your model should include is all key components and observations. So when you're drawing your model, does your model show everything that happens in each of the scenarios? So let's look at this model right here. Okay. Does this model include all the key observations of what you saw happen? What do you guys think?
Yeah.
I would say yes, right? The pans were here, and then they were here. So everything that you could see is illustrated in, thank you for that, it's illustrated in this model. Okay, so when it comes to the model, the very first thing is your model should show everything that you were able to see. Okay, the second thing that your model should be able to include is it should illustrate the relationships among different things. In other words, why did they fly off? I should be able to see in your model some sort of reason as to why this stuff flew off. Okay, so this model here, while it includes number 1, doesn't include number 2. So whenever you're drawing your model, there should always be something that shows the relationships. So down here, this one down here, it attempts to explain why. Again, we're not talking about whether it's right or wrong. We're just saying every model should show some relationship. So there should be some reason as to why the pans flew off. So this one down here talks about, I can zoom in. It talks about how there was no electricity, and then there was electricity, and so they flew off. I don't know if that's right or wrong. We'll talk about that later, but at least for right now, it shows some sort of relationship. Okay, so the first thing is include all key observations. Second, illustrate relationships. Third, it should include labels. Pans, no electricity. Those are all good labels. Okay, so your model should include labels of some sort. All right. The fourth thing should be neat and organized as much as possible. I know you guys are drawing either on your phones or on laptops, and so the neatness is probably not going to be there for right now, but your model should be neat and organized as much as possible. And then the last thing is there should be some sort of prediction for the cause and effect. So here, there's no prediction, right? It shows what happened, but there's no prediction as to the reason why it happened. Here, there's at least some sort of prediction, right? Electricity caused it, whatever. So eventually we're going to have like assessments and stuff like that for the online classes. These are 5 things that you will need to know. Okay, so whenever we do an assessment on this stuff, you will need to know these 5 things. Okay. They were in the email from before. I'm also going to put the PowerPoint on RenWeb as well, or at least just this recording so you can have it to review. But whenever you're making a model trying to describe or predict why the pie pans flew off, for example, your model that you're drawing should include all 5 things. Now, we don't know why the pie pans flew off yet. You're not supposed to know yet. It's not, we're making guesses right now, but we don't actually know. Okay, so the first thing I want you guys to know is simply how to make a scientific model. That was the first section. Now we're starting to get into the nitty-gritty of the scientific reasons why everything was happening, of why things start to stick together. So you guys did a tape lab, or hopefully attempted to do a tape lab, where you peeled off some layers of tape, and you looked at how they were drawn to each other or repelled each other or whatever. Were any of you guys able to actually successfully do the tape lab?
Yeah.
Yeah.
Yeah?
Yeah, I did it.
What?
Yeah.
How many of you have no idea what tape lab I'm talking about?
No.
Nobody wants to admit it. I like that. Okay. So the tape lab was designed to kind of walk you through scenarios of why some things stick together, some things don't. So I'm going to bring you to this. You guys all see the website now?
Yeah.
Yeah.
This is what you guys were doing, right? You made 2 layers or 4 pieces of tape. 2 were top, 2 were bottom. You peeled them off and you brought them near each other. Now, the ideal scenario, if you did it right, is the 2 top pieces of tape would repel each other when you brought them near to each other. The 2 bottom pieces of tape would repel each other when you brought them near each other, and then the top and the bottom would attract. I'm not sure if you guys all did that. It takes some practice with doing it or whatever, but that was the ideal scenario. And then the main thing was, on the next page, you guys looked at a simulation that dealt with magnets, right? Are magnets that you can add charges to it, okay? And the whole goal of this was to illustrate like that the tape represented or acted like the magnets do. Okay, so if I add a positive here and a negative here, they go together. If I make this side positive, they're going to repel. So the idea of this page, which was technically yesterday's assignment, was to relate how each of these charges, the magnets, acts like the pieces of tape. And so the ultimate goal is that you guys understand that when you talk about why the model here, why does it represent the tape strips, is because they are attracted or repel in the same way. So the ultimate conclusion then from this, hopefully that you guys got, is that the tape, when it's separated from other tape, acts like a magnet, which means the tape gains a what?
Charge.
The tape gains a charge. So we're going to talk about why does the tape gain a charge and how does that affect the stickiness of the tape. Because that's kind of what we're looking at, is why things stick together. So for right now, the main things I want you to know are, 1, the 5 pieces of a scientific model. So when you're drawing a model, and I don't think you drew one here, you just took a snapshot. But when you're drawing a model, it can include all 5 of those things. And then the second thing you guys need to know is, when you separated the tape into the different pieces, that some of them act like a positive charge and some of them acted like a negative charge. And when you separate them, somehow the tape is gaining a charge. and we're going to look at how that charge affects the stickiness of objects, because it's not just tape, it's also clothes or other things or whatever. Sorry, I'm just scrolling down for your pictures you guys are using for right now, and that's fantastic. I love it. Great pictures. So those are the things for right now. Where we're going to get to, you guys are going to do some of the stuff on Google Classroom on Thursday and Friday, where you're just like typing up definitions, summarizing what you've learned up to this point on Friday. And then starting next week, that's where we're going to really start diving into the science behind how do things gain charges, what are those charges with like electrons and protons and all that stuff. And we're really going to get into the more scientific details of all those things. Okay, so again, this was super short, but there's not a lot that we've gone over yet. So are there any questions you guys have over any of that stuff?
The sound canceling. Oh.
I'm just waiting quietly just to see if there's any questions.
Wait, what happened? Can't see.
Okay, are you guys all, have you guys all understood? I know I have you on 2 different websites right now as far as the learn.concord and now the Google Classroom. Do you guys feel like it's made sense what I've asked you to do or how I phrased it, or do you want me to like phrase it differently?
I think it's pretty good.
Yeah, it makes sense.
Okay.
Yeah.
Besides the hair one, like on Friday or whatever, the one with the hair diagram,
Yeah.
that was weird.
Yeah, some of those things are weird. Hopefully, like I said, oh my gosh, Aiden. So hopefully it will make sense starting next week as we get into the actual science behind why the pie pans did that, why the hair does that. It would be easier if you guys could, use the Van de Graaff generator. That way, it will make it easier. So we'll figure out a way to do that next week. Hopefully, eventually we'll come back and you guys can all play around with that thing and go from there. But yeah. So if you guys do have any questions, you can obviously send me an email or in Google Classroom, you can type it in a chat in Google Classroom as well. But yeah, I've been keeping track of your guys' progress. It looks good for the most part. Yeah, I don't have any issues. So if you guys have any questions, you can let me know. And we can go from there. Good?
Mr. Brock,